Okay, lesson 1.3. We're going to be working with order of operations today and combining like terms. So a little recall on what y'all should know from middle school. When you're raising a term to the third power, that's known as a cubed. So like 3 cubed, 4 cubed, 5 cubed. That cubed, the 2 is the base number, that's the number you're multiplying. 3 is the exponent. That tells us how many times to multiply it. So we have a 3 here, so we're going to multiply 2 3 times. And we'll get 2 times 2 is 4. 4 times 2 is 8. That's how we get 8. So we can do that for these. 3 is our base, and we're going to multiply it out 3 times. So 3 times 3 times 3. 3 times 3 is 9. Times 3 is, 27. 4 cubed. 4 is our base. We're going to multiply it 3 times. So 4 times 4 is 16. Times 4 is 64. 5 cubed. 5 is our base, and we'll multiply that 3 times. So 5 times 5 is 25. Times 5 is 125. So you have square roots and you have cubed roots. Square roots mean you're looking for a number that multiplies into 4 2 times, not divided by 2. You're looking for a number that multiplies by itself 2 times. In this case, it is actually 2. 2 squared, because it's 2 times 2, so the square root of 4 is 2. Like the square root of 16. What multiplies by itself 2 times to give us 16? Well, that's the 4 squared, which is 4 times 4. So the square root of 16 is 4. We can also do that with cubes. The cubed root of 8. Because there's a 3 there, you want a number that multiplies by itself 3 times. So that is 2 times 2 times 2. So our cubed root of 8 is 2. Now, you cannot square root negatives because it's got to be a number that multiplies by itself twice to give you that square root. So 2 times 2 is a positive 4. Negative 2 times negative 2 is a positive 4. So none of these are going to give you a negative. So we can't solve that. However, when we do a cubed root, we can work with negatives. Like this cubed root of negative 8. A negative 2 times negative 2 is positive 4. But if you multiply a negative 2 by it for that third number, you're still going to get negative 8. So that can give us a negative right there. So the cubed root of negative 8 is going to be that negative 2. You can always cube root odd numbers, odd roots. So this could be 5, it could be 9, it could be 101. You can do odds, but you can never take an even root because you can never get a negative on evens because those negatives right there will cancel each other out. So find the cubed root. What multiplies into 27 by itself 3 times? Well, let's just go down, let's try 3. We'll just work our way up. So 3 times 3 is 9 times 3 is 27. So that's 3 threes. So the cubed root of 27 is 3. What about 216? It's an even number, so your best bet is that you're going to have an even number that multiplies up to it. So let's go with our next even number. 4 times 4 is 16 times a third 4, that's only 64. So that's not right. Sorry, wrong button. So let's try our next even number. 6 times 6 is 36 times another 6 is 216. That almost gets us the right answer, but we have a negative here, so we want our numbers to be negative. Negative 6 times negative 6 gives us negative times negative is positive. But if we multiply another negative by it, it will give us a negative. So the cubed root of negative 216 is negative 6. Okay, cubed root again. So we want a number multiplied by itself 3 times. And this one's an odd number, so your best bet is your answer is going to be odd. So let's see, we've done 3. If you do 5 times 5 times 5, you're always going to get a number that ends in 5, and this one ends in 3, which we already know up here is 125. So we know it's not 5. So let's go to our next odd number, 7. So 7 times 7 is 49. 49 times 7 is 343. So the cubed root of 343 is 7. And it's positive, so our answer is positive. Okay, cubed root of negative 1,000, it's negative, so our answer is going to be negative. And this one you could probably guess because of all the zeros, it's going to be 10. We can check that out first. You can guess that it's going to be 10. So negative 10 times negative 10 is positive 100 times negative 10 is negative 1,000. So the cubed root of negative 1,000 is negative 10. Okay, so we can use all of this and more to do order of operations. Order of operations is PEMDAS. Y'all know that. Please excuse my dear Aunt Sally. However, that's really misleading. PEMDAS only includes parentheses. Parentheses are not the only symbol that fall under that P. It's really all grouping symbols. So your parentheses, brackets, absolute value bars, also fractions fall under that as well. So lots of stuff fall under these grouping symbols. So we actually change it to GEMDAS to help us remember that it's grouping symbols versus parentheses. So we'll always do our grouping symbols first, and then we'll go down the list. Exponents is next. So those are like your squares, your cubes. Oh, also grouping symbols is your square roots. Forgot about that one. So your exponents are your squares, your cubes, your fourth power, fifth power. Then you'll do your multiplication and division, but we always do those from left to right. So it doesn't matter which one comes first. We go left to right with multiplication and division. Same thing with addition and subtraction. We go left to right. So let's try these. For A, do we have any groups? No. Do we have any exponents? No. Any multiplication or division? Those are from left to right. Yes, we have multiplication. What is 3 times 5? 15. Do we have any addition or subtraction from left to right? Yes. 2 plus 15 is 17. And that is it. So let's try for B. Do we have any groups? No. Exponents? No. Multiplication or division? Yes. 8 divided by 4 is 2. Do we have any addition or subtraction? Yes. 2 minus 6. Remember, keep the sign of the larger number. 6 is bigger. It's negative, so keep negative. And subtract. 6 minus 2 is 4. So negative 4. Okay, C. Do we have any groups? Yes, we have these parentheses right here. The parentheses do not mean distribute into it or take the exponent. It means do what is inside. 6 minus 2. That is 4. And you can't work anything else out inside your group. So that is all for grouping. Do we have any exponents? Yes. That exponent is 4 squared. That is 16. 4 times 4 is 16. Do we have multiplication or division? Yes. 16 divided by 2 is 8. And do we have any addition or subtraction? No. So that is it. Okay, D. Do we have any grouping symbols? Yes. Remember, a fraction bar is a grouping symbol. So we want to work the top and the bottom out separately. What can we do on top? On top, we can go down our GEMDAS. So do we have an exponent on top? Yes. What is 2 to the 4th? 2 is our base number. We're going to multiply it out 4 times. So 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that is 16 on top. What else can we do on top? Do we have any multiplication or division? No. Do we have any addition or subtraction on top? Yes, we have this minus. 16 minus 1. That is 15. Okay, and then we got this fraction. Fractions are just division. So division are fractions. When you've simplified everything else on the top and the bottom, we can divide it. 15 divided by 5 is 3. Okay, bottom row. For E, do we have any groups? Yes, we have these parentheses right here. We want to do what's inside the group. We're not distributing this. That is not what grouping symbols mean. Grouping symbols means do what's inside. What is 5 minus 1? That is 4. So bring that down. Okay, so everything inside our group is done. So do we have an exponent? No. Multiplication or division? Yes, this is multiplication. What's 3 times 4? That is 12. And then addition or subtraction? Yes, what's 20 plus 12? 32. Okay, F. Do we have any grouping symbols? Yes, a fraction is a grouping symbol. And what are fractions? Fractions are division. So what is 48 divided by 3? That is 16. So that takes care of your group. Do we have any you could have saved that for division later, but you can go ahead and get rid of it here. No exponents. Do we have multiplication or division? No, we took care of the division. We're good with that. Do we have addition or subtraction? Yes, 16 plus 5 is 21. Okay, really big group here, really big problem. So let's take it piece by piece. Do we have any groups? Yes, we have brackets and parentheses. So we want to know what we can do inside. So I like to take the most inside problem first. So in the most inner group, this parenthesis, what can we do inside that parenthesis? We can add. What's 1 plus 6? That is 7. And then in our outside group here, these brackets, what can we do inside of there? We're not distributing. What can we do inside? We can subtract 13 minus 7. That is 6. And you can change those to parentheses. It honestly doesn't matter. So if you want to write 2 times 6, that's fine. Do you have any exponents? No. Multiplication or division? Yes. What is 2 times 6? That is 12. And then there's nothing else. There's no addition or subtraction. Okay, last. Do we have any group? Yes, we have these parentheses. What can I do inside the group? 5 times 4. That is 20. So that's worked out the inside of the group. Then do I have exponents? Yes, we got the squared. That just means 20 times 20, which is 400. And then there's no multiplication or division, addition, or subtraction. That is it. Perfect. Okay, combining like terms. You want to look at your like terms. Those are the ones that are going to have the same variables with the same exponent. So like x plus 2x. Those are the same variable with the same exponent because they don't have one, so that is 3x. But if you have x squared plus 2x, they have the same variable, but they don't have the same exponent, so we don't get to combine those. Those are not the same. Combining means we're going to add or subtract, not multiplying, not dividing. We are adding or subtracting the coefficients. The coefficients are the number in front. So if I give you 3x plus 4x, I am adding the numbers. That x just gets brought down. And then numbers by themselves are always like terms, like 4 plus 3. Those are like terms because they have no variable, they have no exponent. So which terms are like terms? Circle, all the terms that can be combined with 3a. So we want the same variable, it has to be an a, with the same exponent. There's no exponent, well, it's 1. But you don't have to worry about the exponent. It has to be just a. So is negative 14a the same variable with the same exponent? Yes. What about 5ab? It's got the a, but it has an extra variable, so that doesn't count. What else has an a? D has an a, but this is not a like term. Why? Because it's got an exponent. It has to be the same variable and the same exponent. What else has an a? G has an a, but again, it's got an extra variable, so that doesn't count. It has to be just a. H has an a, but that one doesn't count because it has an exponent of 3. Ours does not. I has an a. There's no exponent, so that is a like term because it is just a. And those are the only ones with a. So draw a line, draw a square around the terms that can be combined with 4b. So we want just a b with no exponent at the top. So 5ab has just a b, but again it has an extra a, so that doesn't count. 3b has just a b, no exponent, so that is a like term. Our next b, 4b squared, is not a like term because it has a squared. Our number does not. G has a b, but it also has an a, so that does not count. We can't have an a, we just want b. J has a b, there's no exponent, so this is a like term. It doesn't matter if it's positive or negative. It has just a b with no exponent at the top. Okay, underline all the terms that can be combined with a squared. So we want just a, and we want it to have a 2 at the top. So B has an A, but there's no 2. There's also an extra letter. D has an A and a 2, so this one matches. E has a squared, but it's not the right variable, so that doesn't work. G has an A, but there's no squared, so that one doesn't work. H has an A, but it has a cubed on it. We want squared, so that doesn't work. So just D. And then draw an X through all the terms that can be combined with 5. 5 does not have a variable, no exponent, so we just want a number. Which one has no variable, no exponent? F. F is just 17, no variable, no exponent. All numbers can be combined without a variable. So, let's see if these are like terms. So remember, it has to be the same variable, same exponent. So, for 2a and a, are they the same variable and same exponent? Yes. So if we combine them, let's just add them up. 2a plus a. So we combine the coefficients in the front. This one has a 2. This one doesn't have a number, but it's an understood 1 because there's literally one a right here. So what is 2 plus 1? That is 3, and just bring your a over. Okay, so the next one. Do we have the same variable and the same exponent? No. So that you're just going to write out. We can't combine them. We just write them out. There's nothing else to do here. The third one. Do we have the same variables and the same exponents? No. This one has an extra t. This one does not. So again, we just have to bring them over. We cannot combine We cannot combine them. The fourth one, do we have the same variables and the same exponent on the same variable? Yes, we have an a squared on both and a b on both. So these are the same. So we can combine them. And this one's negative, so we're going to subtract. So remember, we only combine the number in front. What number is in front here? Is an understood 1. So what is 1 minus 3? It is negative 2. Our variables just get brought over. Okay, the fifth one. Do we have the same variable with the same exponent? No, because the first 4 doesn't even have a variable. We can't combine those two 4s if they both don't have an x. So we just bring them over. Okay, the third one. Do we have the same variables with the same exponents? Little tricky, but yes. We still have an a. The a is connected to 3. We still have a c that's connected to 2. And we still have a b with no exponent. They're in a different order, but they're all the same. It doesn't matter what order they're in. So these are the same. So we have a cubed c squared b plus ba cubed c squared. So then we just combine them up. Add the number in front. Remember, it's an understood 1. So 1 plus 1 is 2. And just bring your variables. I'm just going to go with the first one. The a cubed c squared b. Doesn't matter what order you put them in. If you want to pick the second one, that's fine. I just prefer the first one. And the last one. Do we have the same variable with the same exponent? Yes, it doesn't matter that it's a fraction. The only rule is that it has to have the same variable and the same exponent. They both just have an x, so we can combine those. Now, a little different when you got a fraction there of how to combine it. When we add a fraction, we have to have a common denominator. So we can put that 3 over 1. And in front of all your variables, that's just an understood 1, so that's just a 1/3 x. So we need a common denominator. Let me move that a little. So I need a common denominator. What's going to multiply to 3 and 1? We can multiply them by 3 to get a common denominator of 3. 3 times 3 is 9. Just bring the other one over because it's already got a 3. And then we can add their numbers. So 9 plus 1 is 10. Our common denominator was 3. And then, of course, that x. So when you have a fraction, make sure you get that common denominator. Okay, so let's try some. So we're going to simplify each one. We want the variables that have the like terms that have the same variables and the same exponents. So does anything match 8x squared? 2x squared. So what is 8x squared minus 2x squared? 6x squared. Does anything match 3? No, so just bring it down. That is it. Okay, for B, does anything match 5x? Well, we have another x over here. So what is 5x minus 3x? 2x. I'm going to do my variables first. Does anything match y? Nope. So we're just going to bring it down, a positive 6y. And is anything else just a negative, like a number with no variable, like negative 3? Yeah, 4 over here. Your numbers with no variables, those go together. So negative 4 plus negative 3 plus 4 is 1. Okay, C. Does anything match y cubed and a z with no exponent? Yes, this last one. That one has a y cubed with z with nothing. The middle one does not match. The cubed is on the other letter. So the only ones that are correct, that match, are the y cubed z. Again, that's an invisible 1 right there. So what's 7 plus 1? 8. And just bring your variable down. And then we got that leftover, so bring it down. And again, those don't match because this one has 3 y's and 1 z. This one has 1 y and 3 z. That's like 3 cats and a dog. This one's 1 cat and 3 dogs. Those are not the same thing. Okay, D. Oops, went a little too far. I'll fix it. Sorry. Z minus 6yz3. Okay, does anything match just a regular x, no exponent? No, this one does not match because it has a squared. So we just bring 3x down. Does anything match y? A regular y, so negative 6 minus 1. Negative 7. Does anything match 2? Nope, so just bring it down. And does anything match x squared? No, so just bring it down. Okay, E, does anything match h? The other h over here. So 5 minus 7 is negative 2. And then our plain numbers, we can combine always. Negative 6 minus 8 is negative 14. Okay, this one's very important to watch those variables and exponents. So we have an a squared and b squared. What else has both a squared and b squared? This one over here, the third one. So 6 minus 1, that is 5. Bring down your a squared, b squared. Does anything else just have an a, b with no exponents? No, because this one has a square. That's not the same thing. So just bring it down. And then we got this leftover. There's nothing else to match it to. So just bring it down. Oops. 1 second. Okay, so we can use this combining like terms to find, with a little bit of geometry, to find the perimeter area of different shapes. So we want to find the perimeter of this rectangle. Perimeter is found by adding all the sides. We have your length, your width, another length, another width. So your formula for perimeter, we have 2 lengths plus 2 widths. So 2L plus 2W. So what is our length? Our length is x, and that carries over to this side. The side would be x as well. So I'm going to plug that into L. Our width is 2x plus 3, and that carries down as well. So both of our widths are 2x plus 3. And then we just solve it. So we can distribute this. 2 times x is 2x. 2 times 2x is 4x plus 3. Nope, 2 times 3 is plus 6. And then combine your like terms. What goes with x? The 4x. So 2x plus 4x is 6x. And then we just got a number at the end. There's no other numbers, so just bring it down. A last example, we want to find the perimeter of this triangle. We got a base, a height, and the hypotenuse, or you can call it ABC. Some people do that. But perimeter is just adding all the sides. These don't have any that are the same, so we're just taking our base plus our height plus our hypotenuse. So that's not area. That's how you find in the perimeter. So our base is 5. Our height, nope, our base is down here. It doesn't matter. It's the same thing. Then our x plus 7. Then our 2x minus 3. Technically, that's your base, that's your height, but addition is commutative. So if you put 2 plus 3 or 3 plus 2, they're both going to be 5. It doesn't matter what order they're in. So we have just a regular number. You know what? I'll do the x's first. We'll go with the x's that are together. 1x plus 2x is 3x. And then all of our regular numbers. 5 plus 7 is 12. Minus 3 is 9. So our perimeter is 3x plus 9. Okay, so go try the practice for these.